Building a modern web browser from scratch requires deep knowledge of networking protocols and rendering engines. It is usually a massive, multi-year undertaking. Recently, an engineer named Wilson Lin launched a project called FastRender. It is a fully functional web browser built from the ground up, but he didn't write the code for it. Instead of typing out the logic himself, he deployed an enormous digital workforce, a swarm of 2,000 autonomous AI agents working concurrently. Coordinating in parallel, those bots generated nearly 30,000 distinct code commits with barely any human intervention. FastRender demonstrates, for projects like this, the bottleneck is no longer the speed of a keyboard. When a swarm can construct a rendering engine in hours, the human role shifts from building the engine to deciding exactly where it needs to go. The software making this specific level of massive parallel coordination possible is Cursor version 3, codenamed Glass. Open it up, and you'll notice the traditional code editor is physically pushed down into the corner. It serves only as a secondary, fallback interface. Taking up the main screen is an agent management console. This is a unified dashboard built specifically to oversee thousands of digital workers at once. It uses a feature called Cloud Handoff, allowing you to seamlessly transfer these heavy agent sessions from your local machine up to the cloud without dropping a single thread of context. You aren't sitting there sequentially typing out syntax anymore. You are deploying and monitoring concurrent bots across multiple code repositories simultaneously. This turns a single engineer into a high-level manager. You direct overarching logic and architecture while the agents figure out the granular implementation. For users of Glass, the workflow moves away from the line-by-line syntax of a single file and toward the management of a concurrent digital workforce. Generating 30,000 commits at once creates an immediate physical constraint. You need near infinite compute power and practically zero latency to keep the swarm moving. Running this entirely on cloud servers is thermally unsustainable. The solution is the compute continuum. Basic tasks stay on device, using a local neural processing unit, reducing token usage by 60%. Meanwhile, complex logic is dynamically routed to massive centralized server farms. This massive hardware requirement explains the rumored $60 billion agreement for SpaceX to acquire Cursor. The deal gives Cursor direct access to the Colossus supercluster and its million-plus GPUs. With that native, deep hardware integration, Cursor can run continuous background context windows. Your editor remembers every code commit, every Jira ticket, and every Slack message, reducing context anxiety because the system never has to re-index. Managing thousands of agents at once is no longer just a software challenge, but a massive hardware logistics war. The FastRender project serves as a proof of concept for a different kind of development, one where the complexity of the code is handled by the scale of the swarm. The traditional industry archetype of the 10x developer, who relies on typing out code faster than their peers, is fading. A new archetype is taking its place, the orchestrator, an engineer who acts as a CEO to thousands of AI agents. While a traditional coder might still stare at a blank text file in a standard IDE, an orchestrator is commanding massive parallel output across entire workspaces. Developers who do not adapt to agent management consoles are finding themselves in direct competition with automated, non-stop digital swarms. As these tools mature, the competitive edge moves from the ability to write code to the ability to architect and orchestrate these massive, parallel systems to solve complex problems.